Welcome to the Multiplanetary Innovation Enterprise, or MINE for short. My name is Kassidy Vanover, and I serve as this year's Enterprise Manager. I'm joined by several of my teammates to share an overview of our 4 projects: Diver, Extinct, Lunabotics Astro-Huskies, and Trencher. MINE is a multidisciplinary enterprise made of more than 80 students from a wide range of majors, backgrounds, and interests. Together, we design, test, and deploy systems built to operate in extreme environments. Our projects range from exploring the flooded copper mines of Michigan's Keweenaw Peninsula to developing excavation systems for the lunar surface and beyond. Although each project has a unique mission, they all support the same enterprise goal: advancing practical robotic solutions for challenging, high-risk environments through hands-on engineering, research, and collaboration. We're proud to share the progress each team has made this year and the impact these projects can have in both on- and off-world applications.
Hello, my name is Brewer Staley, and I'm part of the mechanical sub-team for Diver. Diver focuses on the exploration and data collection of the flooded portions of old mines, with additional applications in other areas of industry. Our current test case is the Quincy mine, with the long-term goal of mapping its entire 2,700-meter depth and collecting samples using autonomous underwater ROV. This information can be used for the assessment of old mines as locations for push facilities, pumped hydro storage with renewable energy applications. Currently, our focus is on learning as much as possible from shallow water environments like the pool. This has involved developing mobility, sensor integration, and sample collection system designed for repeated tests of our system. Our goal is to learn as much as possible about the unique system we are developing as we continue to build it into a full operational depth design.
Hello, my name is Julian Hong, and I am the project lead for Extinct. Extinct is focused on developing the T-Rex rover, a robotic system designed to deliver power and communications through tether into the moon's permanently shadowed regions, or PSRs. These deep craters near the lunar South Pole never receive sunlight and are cold enough to preserve ice, making them important for future exploration and resource use. T-Rex first deploys a conventional conducting tether, then transitions to a superconducting tether upon entering the PSR. This allows the system to transmit power over long distances with minimal power loss in extremely cold environments. This year, our team has focused on subsystem development, integration, and preparation for a large-scale field test at the Nevada National Security Sites. There, we will evaluate tether tension control, out-of-site rover operation, and power delivery performance to determine mission readiness for future lunar deployment.
Hello, my name is Audrey, and I am part of the Structures sub-team for the Lunabotics project. Each year, our team competes in NASA's Lunabotics Challenge, where we design and operate an excavation and construction rover for off-world applications. The competition centers on building berms for lunar regolith, which can help protect future lunar infrastructure from debris during launches and surface operations. NASA also uses data from participating teams to help inform future strategies for sustained lunar missions. This year's rover features a single bucket skimmer, a belt system for regolith storage and deposition, and 4 independently powered and steered wheels for mobility and maneuverability. Our team is currently in the final stages of system verification, testing, and documentation as we prepare for competition submission. Through this project, we combine design, manufacturing, controls, and system integration to create a rover for real lunar construction challenges.
Hello, my name is Jack, and I am the project manager for the Trencher project. Trencher is a research-driven initiative focused on increasing the technology readiness level of NASA bucket ladder excavation systems for lunar use by advancing them towards readiness level 5 through structured testing in atmospheric and simulated lunar environments. Our team designs, builds, and tests bucket ladder excavators capable of operating in conditions similar to future lunar surface missions. Over the past year, we have concentrated on the design and manufacturing of our current system, the Lunar Ladder, which is designed to alternate with NASA's Moonraker excavator and interface with the Hoplite rover in the PSTDL lab. To evaluate performance, we track key metrics including excavation rate, mass displacement, and power consumption over time. This data allows us to compare current and past test campaigns, validate design improvements, and support the development of excavation systems for future lunar infrastructure.
The Multiplanetary Innovation Enterprise offers students from many majors the chance to gain practical, real-world experience through active participation in the engineering process. Within our 4 projects, team members have the opportunity to contribute to mechanical and electrical design, manufacturing, programming, testing, and much more. Our hands-on approach ensures that each member gains valuable experience from the ideation and initial design phase all the way to the manufacture and testing of the project. I'd like to extend a special thanks to our members, our faculty advisor, Dr. Paul Van Susante, and our sponsors for their dedication and support in helping us make significant progress this past year. On behalf of Multiplanetary Innovation Enterprise, thank you for your time.